Hey, Vlad here, devinsideyou.com. Welcome to another video. In the previous couple of videos, well, actually quite a few videos, we talked mostly about general tools, and I guess we can all agree that it's time to go back to Scala. And so today we're going to play around with a cool little library called Chimney. I have to admit I haven't heard of Chimney until a couple of weeks ago, but it certainly piqued my interest. It's one of those cute little libraries that help you reduce some boilerplate. The benefits it offers are a bit limited, but in cases where it does work, it works like a charm, and when it doesn't, it fails at compile time in a crystal clear way, and so there won't be any surprises. Now, before we begin, I would like to mention that Chimney is actually very well documented. In fact, once I saw the docs, I was a bit worried that making a video about it is not going to add much value, but then I realized that it's actually a very young library, it's under 2 years old, and so it could use a bit more exposure, and so here we are. Having said that, I didn't want to just go and parrot the documentation, and so towards the end of the video, we're going to have a slightly more larger and also realistic example, which among other things includes the beloved functional programming library called CATS. And also there are a couple of other libraries that I have been meaning to check out that are all related to manipulation of data structures, and so this video might be a beginning of a new mini playlist. Alright, I'm going to stop talking now. Let's roll the intro. As in most of my videos, I'm on Windows and I'm also running an Ubuntu 18.04 virtual machine, and I'm using the Windows Virtual Desktop feature, which gives me shortcuts so that I can go back to Windows and go back to my virtual machine like that. Alright, so what does Chimney do? Chimney uses both black and white box macros to generate transformers for flat data structures, no relation to mono transformers. Now, that's a mouthful, so let me paraphrase. If you have a simple data structure, which in Scala most of the time means either a case class or an ADT, which are synonyms for products and core products, then you can quite easily using Chimney transform or convert them, or use whatever word you want, into other data structures. Chimney essentially pattern matches on field names of your data structures at compile time, which is one of the things it needs macros for. For instance, if you have a simple data structure, a simple case class called person, which has a name and an age, and you want to transform it into a different data structure called customer, which has exactly the same fields with exactly the same names, but let's say in addition to that, it has its own field called ID. So instead of transferring every field manually, Chimney does it for you. It might not be so easy to imagine, so let's go ahead and set up a Hello World project to play around with it. If you've been following my channel for a while, then you know that I have generate templates to set up default projects. So if we go to ga.devinsideyou.com, we're going to see two of my generate templates. We're going to grab the Scala seed. We're going to copy this line over here, and we're going to go back to my VM. I'm going to press F12. Gwake is going to come down with Biobo inside, and I've changed all of my color themes again. So if you're interested in my kind of setup, I have videos about all of that stuff. So all we need to do is I'm going to go into my dev folder, which is currently empty, and I'm going to just paste what we just copied. I'm gonna press enter, so it's now gonna start cloning the project. All right, so I'm just gonna go and call it playground, and the organization is gonna be dev inside you, and the package is gonna be just dev inside you, like that. Okay, so now I can just go ahead and open this with Visual Studio Code like this. There we go. All right, now and done show again. So I'm using this template for my real projects, but for tutorials, I'm actually going to go ahead and disable a couple of flags. I'm just going to go down over here, and I'm going to go and disable, I believe these three should be enough, like that. Maybe also language. We probably don't need language. Okay, and also I want to go ahead and I want to add Chimney right away because I want to use Bloop, and I don't want to be re-importing the build all the time. So I'm going to go back to the dependencies file. If you have seen the video where we set up this template, then you shouldn't be surprised. So, but basically, this is a typical thing where you have a dependencies.scala file, sort of like one layer deeper, so that you can use them in your build file. Okay, so I'm just going to go ahead over here, and I'm going to go and create a file, another file. I'm going to create an object called I'm going to call it util, and over here I'm going to say Chimney equals, and the group ID is Scala land, like this. And it's a Scala dependency, so we need two of these symbols, so it's called just Chimney, and the latest version at the moment of recording is 0.3.4. And by the way, it also works for Scala JS, and I believe even Scala native, and it also works for Scala 12 and Scala 11, 2.12 and 2.11. We're using 2.13.1 over here. All right, so I have a bunch of dependencies over here. In fact, recently I started separating my test dependencies with my from my regular dependencies. So over here, I'm just going to do map like this test, and now I can remove all of these. Okay, like that, all of these three. And over here, I'm just going to duplicate this line. And I'm going to do that. I'm going to do comma over here. And now I can just do over here, I can just say dependencies dot util dot chimney, like this. Okay, so basically over here I have my production level dependencies, and over here I have my test dependencies. Okay, so let me import the build for Bloop, and also in another terminal. Let me just go and start SBT over here. SBT like that, and while it loads, let me actually show you the important part of the build in case you haven't seen this video, but it's actually just a few places. So we're using Scala 2.13.1, we're using SBT 134, which just came out a couple of days ago, and we're also going to use the kind projector plugin. Let me actually go and show you the dependency over here. We actually don't need it for Chimney. We're going to end up needing it just for, for this bigger example at the end where we're going to use cats. And in fact, we also don't really need it in our case because, in our case, we're going to use it in one place. So I'm also going to show it to you how to use it without. Okay, what happened here? It probably collided with Bloop. Let's try this again. And there we go. All right, so let's just run the test. This is what I usually like to do in the beginning. Let's just run the test, and yeah, so I have a bunch of aliases for tests and run and all of that stuff. Okay, and then we can just run the main method, which is somewhere main method. Okay, this is what we have. All right, Scala form. Everybody's happy. Terminal. We have terminal. Let's bring it down over here. All right, now we can finally start writing some code. Most of the things that Chimney does for you, they come from one simple import. Unfortunately, it's kind of long, but still. So we go io scala land dot chimney dot dsl underscore, like this. All right, so let's go ahead and remove this print line, and let's say that we have a final case class person, which is exactly what I was talking about. It has name string, age int, and we're going to duplicate that, and we're going to call this one customer, and let's say just for fun that the customer also has an ID, which is going to be a UUID, which is the typical Java thing. Let's also not forget to go and import it. Let's go over here, import java.util.uuid. Yes, exactly this one. Okay, let's see if it compiles. It does. Okay, so now let's go ahead and create a simple person. I'm going to do person. When I'm recording tutorials, I usually like to annotate all the types. So let's go ahead and do a person like this. I'm going to say name is Bob and age is, I don't know, 27. Like this. Okay, so now what we can do is, oh, that's actually an integer. All right, 27, like this. So what we can do now is we can go and create a customer, right? And instead of manually transferring all the fields, we can just say person, and then this is where Chimney comes in. We can say into, and we're going to specify the parameter. We're going to say that this is going to be a customer, right? So basically transforming a person into a customer, okay, like this. And at the end, so this basically creates a transformer, but we don't want the transformer. We want actually the customer. So at the end, we actually also have to say, transformer, please transform that. And if we're going to compile that now, it's actually not going to compile. And I'm doing this so that I can show you the crystal clear error messages that are coming from Chimney. It says Chimney can't derive transformation from dev inside your playground main person to dev inside your playground main customer. And it says over here, UUID, no accessor named ID in source, right? So as I mentioned in the beginning, it basically pattern matches on the name. So it was looking at for the name ID somewhere in person. It couldn't find it, and this is exactly what it tells you. Okay. Now there are multiple ways to solve this issue. So it comes with a bunch of helper methods. One of them is called with field computed. Okay. So over here we can say with field computed. Okay, so as you can see, it wants a selector, right? So which field do you want to compute? Well, I want the ID field, okay? And now it also wants to know how are you going to map a person to, to this UUID. In our case, we're actually not going to need the person because in our case, we're just going to generate a random UUID. So we're going to do underscore arrow to the right, and we're going to do UUID dot random UUID like this. Okay, so now it actually managed to transform that, right? So instead of doing like all of these things manually, you just, ask Chimney to do, most of the things for you. And if some things are missing, you kind of help it out. Okay, so now let's go and not forget to print out the person, and print out the customer. No big surprises over there. This is exactly what we have. So this was some random UUID that was generated, and we still have, name and the ID. I'm sorry, I meant age. All right, so there are a couple of other helper methods. So for example, instead of with_field computed, we can actually go and say with_field const, right? So in our case, because we didn't need, we don't need the access to the person, we just generated something random, we can also go and just say ID, and over here we can do UUID, random UUID, like this, okay? And notice that it's totally fine that we specified it multiple times. It's just gonna take the last one. Now let's have an example where we actually, use this parameter. In fact, most of the times when you're going to work with Chimney, you're not going to use this parameter anyway, because you have access to the actual object that you're transforming, right? So this is only like for really advanced things where you create a transformer somewhere here, but you use it somewhere later, and so you don't see, which object it was called on. So this just gives you access to it. Okay, so let's go and change the customer, for example, to say that this is not the age. Let's say that this is the birth year, like this. Okay, so now these things are not going to match. Okay, and what we need to do is we just need to go and say, okay, so we still need the ID. So let's remove this one. Okay, and we're going to go over here, and now we're going to say with_field computed. Okay, we're not going to compute a different field now. So now we're going to do the birth year. Okay, and how we're going to compute it? Well, we're going to say local date dot now dot get year minus, and now we have the access to the person, right? So this is the underscore, okay? And now we can ask it for the age, okay? Like this, right? So the person still has the age, and now we can compute the birth year. We just need to not forget to import the java.time. I believe that should be enough. Okay, let's see. Okay, so if Bob is 27, I'm recording this video in 2019. 2019 minus 27 is exactly 1992. Okay, so in case you're not familiar with Lambda syntax, we can also do this, right? So this is the person that comes in, and this is this underscore over here, like that. As I already mentioned just a second ago, we actually, most of the times, we don't need this with_field computed because we can just go and say, so I'm going to duplicate that. We can just say with_field const, and because, so now we don't have a lambda over here, but we still need this p, but we have access to the person, right? So we can go over here and we can have access to the person, right? So we don't need this thing. It works exactly the same. Yet another helper that we have is called with_field renamed. So let's go and say that these two don't match anymore. Let's say that this one is called full name, okay? So if we save, it's going to bark at us, okay? And we can go and we can say, we don't need to sort them, but I kind of want to, sort them for simplicity, like this. So we can say with_field, okay, bloop's not helping, with_field renamed. Okay, which field do we want to rename? Well, we want to rename the name field, and what we're going to rename it to? Well, to full name. Okay, like this. Okay, and it's going to fix everything for us. Now, as you can see, like most of these, they can actually be expressed with the with_field computed. In fact, there's pretty much only one use case where with_field rename is a bit more superior to the others, and this is the one that I'm going to show you in a couple of seconds. For now, let me show you how to do the same thing with the others, right? So you can go and say with_field computed. Okay, which field do we want to compute? Well, we want to compute the full name field, and what is going to be the value? Well, the value is going to be name, like this. Okay, and also we can do the other way around. We can say with_field const, right? We can do full name, okay, and because we have access to the person, we can just do person dot name, right? So all of these, they're basically the same, but as I just mentioned, renamed is a little bit superior, and I'm going to show you why. I believe pretty much the reason it exists is because of this. So Scala has a concept of any vals, and Chimney understands any vals. Okay, so if you have final case class name, for example, with some value, okay, and it extends any val. It's not going to work without any val, by the way, okay? And you go and you say, so the original person still has a string as a name, but the customer actually has the name, like this, okay? So now let's see what's going to happen. Now it doesn't compile. It doesn't compile in... I actually was kind of hoping that it only wouldn't compile over here. Hold on, let me try that. Yeah, okay, so it was just just an error which was displaying wrong. So as you can see, with_field renamed understands that it can map a string into a name, okay, just as a reminder. So name is a string, full name is now a name, right? So now it can lift it for you. As you can see, it was just Bob, and now it's name Bob. And as I already mentioned, it's not going to work without any val. Okay, right? So if you're just doing a case class, it's not going to work. Okay, no accessor name value, blah, blah, blah. Okay, let's revert that. And so as you can see, it's a little bit superior, because if you do with_field computed over here, right, then you would actually need to go ahead and make sure that you wrap this whole thing into a name, like that. Okay, like this. And missing parameter type. Maybe I need to do like that. Maybe it's going to be happier than like this. Yep, it's happier now. And the same thing was this field const. Okay, so we need to take this thing. Whoops, we need to take this thing and manually wrap it into a name like this, right? So as you can see, in this case, was field renamed is a little bit superior. Okay, let me remove these two. And obviously, if the field names match completely, right? So this one is a name string, but this one is a full name. But if they match entirely, right, then you don't even need the renamed. Okay, so Chimney is just going to do this for you. And I hope it was obvious all along, but if all the stars align, right, so if everything matches, so for example, let's remove the ID over here, right, then we actually don't even need these two. Okay, we can just go remove that. Let's not have birth year. Let's say that this is age again. Okay, so remove that, right? So in these cases where, you know, basically the whole thing matches, then you don't have to do anything. Chimney is going to do it for you. And also in cases like this where, basically all stars align, Chimney has a helper method which saves you one dot. So if we do that, if I write it like this, then instead of that, you could actually also say person transform into, right? Transform into customer, right? So it basically saves you this one character. I'm not a big fan of it, so I'm actually going to go and revert it after I show it to you. There we go. Does the same thing. So let's just go and revert that until like this. All right. Cool. Now, Chimney also understands default values, right? So, for example, if your target, which is the customer, let's say if it has an email, right? So now obviously it's not going to work, but if it had a default value like a@b.com, then Chimney is going to grab it unless you disable it explicitly. So you can go over here and you can say disable default values like this. Okay, and now it's not going to work. Let's see the error message. Okay, so it's basically the same error message as before. Okay, it also understands optional values, and optional values, they actually sort of work the other way around. So if email was an option, okay, so if this was an option, let's remove the default value because I want to show you that it sort of works the other way around. Okay, so if we have that, now it's still going to say, hey, it's not there unless you specifically enable it, right? So for default values, you have to specifically disable it, and for optional values, you have to specifically enable it, right? So you go and you say enable optional defaults to none. Okay, like this, enable option defaults to none. All right, so we're not done with transformers, but I want to show you a different concept that Chimney has, which is patchers. Let me revert that real quick and also say that an email over here is a string, and let's also add an email to a person like that. Okay, so let's go over here and let's specify an email like that, a@b.com. Like this. Okay, so now we're transforming person into customer the same as we did before. Now let's say that we had a patch, right? So we had a patch, separate thing, case class. We don't need to call it patch, but so I'm going to call it update. And this update, it doesn't update every field. It updates only a subset of fields. Okay, so let's say it updates the name and it updates the age. Like this. Okay, so now that we have this update, we can we can create an instance of it. So we can go over here and I'm going to call it patch now. So because the type is patch. Okay, so we're going to go and create it, update name, and okay, so let's change the name to Frank, and let's change the age to 45. Okay, so what you can do now is first of all, we need to import patch. So we also need a different import over here, io.scala-land.chimney. Okay, this one. Right, so this is pretty much all we need. Oh, it's not called patch, it's called patcher, I think. Oh, what am I doing? Oh my God. No, this is still an update. In fact, you know what? I'm going to call it patch. I'm going to call it patch, and we actually don't need that import. I'm sorry. It's kind of still early in the morning for me. Anyway, okay, so we have the person and we have the patch. Okay, so now we can apply the patch. And go over here, we can say patched person, right, which is still a person, is going to be a person dot patch with, and we just give it the patch like this. Okay, and we can do the same thing with the customer. So we can do a patched customer, which is a customer, and we're going to do the same thing, customer patch with patch, right? So this patch, it applies for both the customer and the person. So we need to go down over here because I'm using the customer over there. Like this, and let's actually go and duplicate that, bring it up like this, and let's print line the patched person, and also let's print line the patched customer. Come on, Autocomplete. There we go. Patch customer. All right. So let me have a bit more space over here. Okay. So we had the person and the customer, but then we patched both of them with a different name and a different age, like this. Okay. So the patch worked for both of them. All right. So let's go back to transformers. So Chimney also knows how to work with coproducts or ADTs. So what I'm going to do is I'm going to disable these print lines for a bit, and I'm going to go back and paste something over here which comes straight from the documentation, because this example is really good. Okay, so I'm just gonna go and press Control Shift V. I wanted to press Control V. Okay, so we have a simple ADT, right? So we have a bunch of colors, red, green, blue, and we also have a bunch of channels, right, which are also red, green, blue, but it also has alpha. Actually, why is it like this? I want it like that. Okay, red, green, blue. Okay, so what we can do now is we can go and create a color, right? Val color, which is a color, and let's say that this is color dot red. Okay, red, like this. Okay, so let's also go and create a channel, and we're going to use Chimney to transform this color into a channel by saying basically the same thing. We're going to go and say color into channel, and we're going to say transform, like this. Okay, let's go and print out print line color and also print line channel, like this. All right, so we see red and red. One important thing to know about this is that the type has to be color, so it cannot work with color.red directly. So if we're gonna go, for example, take this one and then line it over here, it's actually not gonna compile. In fact, I have a hunch why it doesn't work, and I'm gonna show it to you later. Okay, so let's revert that for now, like this. Okay, now going back the other way is actually not gonna work so easily. So if we're gonna go and we're gonna say val back to color, which is going to be color. So now let's take this channel that we just created with the help of Chimney, and we're going to go back to color, okay, and we're going to ask it to transform. It's not gonna work, because basically it's going to say that it doesn't know how to map to the alpha channel. It says can transform coproduct instance alpha to color, right? Because again, it doesn't see exactly which type you're transforming, right? So it just sees that it's some sort of channel, right? But because it doesn't know how to map alpha to the color, it basically fails. And the same as, as Wisfield cons and Wisfield computed, there's a special one for coproducts called Wis coproduct instance, like this. And the signature is a little bit weird, but basically we need to pass it a function, okay? A function that will basically say, okay, so if it's a channel alpha type, okay, well then in this case let's map it to, I don't know, let's map it to blue, okay, like this, right? So in our case it's not alpha, right? So it's still gonna map it to red, but in case we had okay, so we need over here we need a channel. So if we go and we do channel dot alpha, right? And again, it's not going to compile like this, right? Because we need to help it with the types. We need to say, please use it just as a channel. Then it's going to see that, oh, we're actually not printing it out. Print line back to color. Okay, back to color. Okay, and before it was actually just channel. Okay. Right, so it mapped alpha to blue just now, and now it maps channel as before, so it basically doesn't need to do that because it wasn't alpha, so it just mapped red to red, the same as before. Also, I noticed a weird behavior in Chimney. If you accidentally try to convert the data structure into itself, then it's going to fail in weird ways. Okay, so for example, over here we have a val channel, and so we're taking a color and transform it into channel. What if we make a mistake and type in channel over here? All right, let's see. In this case, okay, there's a match error with a null. Hold up. Let me just do that like this. Okay, so now as you can see, it compiled somehow. I'm actually not sure if this is a Scala bug or something, right? Because we're referencing channel, which is a val that we're creating right now, and yeah, so in general, be very careful when you sort of accidentally convert something into itself. So for example, if we go over here and we're going to say C, which is a color, and we're going to take the color from the top and we're going to transform it into color again, dot transform, like this, right? So in this case, it's just gonna basically fail silently, not fail silently, basically it's not gonna do anything. Okay, in fact, I'm realizing right now that I probably should have had a better example. So essentially, always be a little bit careful when you're transforming. Just make sure that the types are aligned and that the types are doing actually exactly what you wanted them to do. Okay, so let me remove this color example, and we're actually going to go back to transformers. And the transformers are usually generated by macros, but you can actually provide your own transformers, right? So it's simple type classes, and I have a video about type classes, right? So basically, you can create the instances on your own. Okay, so for this we need this extra import, okay, this one, right? Because inside of this we have the patcher and we have the transformer. Okay, so we're going to use the transformer first, and then we're going to use the patcher. Okay, so if we go and we create somewhere, let's do it over here. Okay, so we can do implicit val, and we're going to say person to customer, right? And we want to, and this is going to be a type of transformer, well, from person to customer. Now, because transformer, and we're gonna hold on, we're actually gonna do this. Okay, we can't do that because now it's just gonna explode. What's up with that? What? Where? How? An implementation is missing, but it's a def. Oh yeah, because it's an implicit def, it's still being called. Okay, there we go. Okay, so let's have it like this. So now we can jump into the transformer, and it's just a function. You know, was a very simple method, right? So it's just a basically typical function. By the way, because we don't have you know, the contravariance and the covariance annotations here, I believe that this is one of the reasons why you know, this conversion between colors, why it needed you know, explicitly the type color and not, for example, color.red. In fact, I was actually so curious that I cloned Chimney and I added that and everything compiled, but when I was using it, there were some errors related to macros, and I didn't keep investigating further. Okay, yes, this is a read-only file. I know. Okay, let's just go and close. Now, because this is a SAM type, we can actually use a simple function to implement that, right? So we can basically say, okay, if the person comes in, then this is how we're going to create a customer. Let's for fun say that this is going to be a person name, and because I want to show you that this is, you know, this is exactly the one that is going to be applied, I'm just going to, you know, ruin a little bit like this. I'm going to do that, and I'm going to do person.age plus 10 just for fun. Okay, so now this is going to be an implicit val over here, and person.name. What's up? Oh, we don't have an email. We actually done. I'm actually going to remove the email. We don't need the email. What else? Maybe that's actually enough. Okay, found string, required name. Oh, we actually needed to wrap it to name. Or maybe let's just use string over here. Doesn't really matter. Let's go and use string over here. String. Like this. Okay, so now I just went ahead and where is it actually? Are we printing this out? Person customer, it's these first. Okay, so this is, so basically we had a person Bob 27, and we converted into a customer Bob line 42, and we had 27 plus 10, right? 27 plus 10, right? That's exactly what we did. So this is why 37 came out, right? So now you can have your own transformers which don't match on the names, which don't do anything weird with macros, and so you know, you can have a bit more control. And now we're gonna go and go ahead and do the same thing for patchers. So we're just gonna comment this one out. Okay, so now the behavior is back to normal. We're going to do the same thing for the patchers. So we're going to go and say val custom patcher, which is going to be a patcher from, so it's going to be a patcher for customer, and we're going to be able to patch an integer inside of the customer. Okay, so what we're going to have is, so the patcher, it looks a little bit different. I mean, only a little bit. We're going to jump into it actually in just a second, but essentially it's a function that, you know, that takes your customer and takes the new value. For example, you know, the only integers that we have is the age. So we're going to have customer new age, and we're going to have the arrow to the right, and we're just going to say customer.copy age equals new age. Okay, so you can't use Chimney here, right? Because otherwise it's going to, you know, recurse into itself, right? So we have to do the old school, you know, customer copy. And also, like, this is one of those things that I was saying, you know, if you try to use Chimney to convert a type into itself, right? So you know, we can't convert a customer into a customer. You're gonna have issues. Okay, so basically just gonna ignore your update. Okay, so this is basically what's happening. So now we can go and, for example, we can just go and print out a customer, which is probably at the bottom. Let's actually go and cut this out. Let's go and over here, let's duplicate that one like that, and we can go over here and we can print out a customer, but we're going to patch him with 25. Okay, so now it's going to be Bob 25 because we patched the integer, which was the age, was 25. All right, so we're pretty much done with the Chimney tutorial. I actually left a couple of things out for you to experiment with the documentation because, as I said, it's actually really good. So let's take a look at a bigger example. And what I'm going to do is I'm going to go and I'm going to create another file called, I'm going to call it structure. So what I want to show you is how Chimney can essentially, take an entire hierarchy and transform it into another one, so to say. So I'm just going to go here and I'm just going to paste a slightly larger example, as I already said. So let me actually walk you through this. So this is essentially, maybe we should start at the bottom. So this is just a person, right? So at the end of the day, this is just going to be a person. It's going to have a name, it's going to have a phone, and it's going to have an address. Right? So, but everything is sort of, heavily typed, right? Everything is heavily typed, a bunch of any vowels over here. So for example, person.name is just a case class, which has a value string. It extends any val. And what I like to do is to override this product prefix in such a way that, the toString for the name is going to look like person.name. Right? Because we're going to have a bunch of names. We're going to have like a street name. We're going to have a city name. And, when we print them out, I want to see the difference. Okay, so this is the pattern that I use all over the place. Okay, so we have a person, it has a name. We've already seen the name. We also have the phone, which is over here, just a case class phone. Okay, we have address, which is another nested class. So it's an address. It has a city and a street. City again is a city has a name and a zip code. Again, all of these are, extends any val, but essentially everything boils down back to strings at the end of the day. Okay, so we have the city and we also have the street, which has a name and a number, right? So this is like a nested things. Okay, and each one of them also has a raw version, right? So the raw version is the one that basically uses plain strings. So we're going to go to person, and somewhere inside of it, we're going to see the raw version of the person. Okay, so basically it has a name, but it's just a string. It has a phone, but it's just a string. It has an address, and it's the raw version of the address. So if we actually jump over here, this is just, also city raw, street raw, everything is raw. So if we keep like jumping into these, at the end, we're going to see, okay, it's actually just a string. Okay, so now we can go over here into our main method. And in fact, what are we going to do? I'm going to go and I'm going to say that this is main 2. I'm going to duplicate this line. I'm going to say that this is main 1, like that. Okay, and we're going to go and we're going to say, I'm going to duplicate this like that, and I'm going to do a hello world, print line, hello world, like this. Okay, so let's actually run it once, and let's actually, oh, did I type in Q? No, I didn't want to do that. Oh, all right, all I wanted to do was to say run main, like this. Okay, so that it chooses the one, this one for us. That's not main, it's it's dev inside you dot playground dot main, like this. All right, so now we have our main. Oh, it barks. SPT barks at us. This warning should not exist. Okay, right. I know that there are multiple mains. This is exactly why I'm running only one of them. All right. Okay, cool. So now we have our hello world. So let's go back and actually let me copy paste this because I don't want to waste your time. So essentially, we're going to create a raw version of the person, like this, right? This is a person, right? So it has a name, a phone, has an address, has a city, was name and zip code, has a street, was a name, and the street number. Okay, so now we can go over here, same as before. We're gonna go and say we're gonna have a person, val person equals raw into person. Okay, and we're gonna say transform, same as we did before. Okay, so now we can print out raw. And now we can print out person like this. Let's see. There we go. So this is the raw version, which basically just has a bunch of strings, and we have a full-blown nested one. I mean, both of them are nested, but this one is nested in such a way that every string is also wrapped into its own any val. Okay, so we have person name, we have the phone, we have the address, we have the city name, city zip code, all of that stuff, right? So essentially, Chimney just managed to lift a hierarchy which matched exactly the other one, right? But and the other one was more heavily typed, right? So basically, it's just, this essentially one line, and it managed to do this for you. All right, so now let's talk about the things that I'm sort of, I don't want to say that I'm unhappy. It's just that, the things that I want Chimney to do, Chimney was not designed to do. So let me give you an example. So usually what we had so far, we had a final case class, person. I'm going to call it P because I don't want it to collide with the other person, right? So we're going to have name, string, and age int like this, okay? And what we had, we also had the customer, so I'm going to do a C over here, right? And we had ID, UU, ID like this, okay? So basically, when you structure your data structures like this, then Chimney is actually really helpful. However, what I usually like to do is I nest them, right? So I do final case class. I'm going to call it C1 because, you know, I don't want the collision. Okay. So what I usually would do is I would do this UUID, and then I'm just going to put an entire person in there. Right. So I'm going to do that. And now Chimney is basically useless because Chimney, you know, it pattern matches on the field names. Right. But it can't, you know, it can't understand that this name and age that they should be packed into a person. I'm sorry, this name and age that they should be packed into a person. And the same thing basically applies to patchers. Right. So now neither the transformers nor the patchers are going to work. And because I do this, you know, it's gonna become even more, you know, even better in Scala 3 because Scala 3 is gonna come with a feature called export, and I'll be able to do this. I'll be able to say export person like this, and now from the outside, if I have, you know, if I have this customer, I'll still be able to go straight to the field's name and age, right? So I'll be able to say c.id, c.name, c.age because of this export. So so yeah, if you structure your data structure like this, then it's going to be a little bit less useful. And another thing that I want to say is that, you know, it is helpful when it matches everything like perfectly, right? So all the names, all the fields, I'm sorry, all the fields, all the names, and also all the types, right? So the types basically match, right? So we just lifted a bunch of strings into a bunch of any vals which were designed for strings. However, if we go ahead and add another field, which is going to be an integer, it's gonna collide, right? It's gonna it's not going to work. So let's actually go ahead and do that. So we're going to go to structure and we're going to add a field called age. So where is it? Okay, so we have a name over here. So we're going to go ahead and we're going to say that we also want the age. I'm going to want the age, and it's going to be person.age. Okay, and the age. Oh, I'm sorry, I added it to the raw one. Hold up. I'm going to do this later. So I want to do it over here like this. Okay, so we have a person which is with age now. Okay, so let's go and let me copy paste that. Right, so we have name. I keep pressing Control Shift V. Okay, so this is now age. Okay, this is now age, but the value is now an integer. Right, so this is now an integer over here. Okay, so let me go to the raw and also say that this is going to be an age, but the raw age is still going to be a string. Now, why is it a string? Because the use case that I'm sort of trying to work with here is that if you have a form, you know, on your website or wherever that you know, people fill out stuff, you know, the age is going to be a string, and but in the end, you know, your entity is going to have the age of int. Okay, so let's go and try to compile this. Probably not going to compile because we also need to go to main and also specify the age over here. So name age is going to be, I don't know, 37. Okay, I forgot the comma, like that. Okay, so we have 37. So now it's not going to compile, right? It's basically going to tell you, hold up. It basically is going to tell you no accessor name value in source type Java-lang string. Okay, so it basically tried to access this field, right? And it just basically failed. Now we already know sort of how to fix this, right? So we can go over here, right? And we can say, for example, I don't know, with field computed, okay? And we can say, you know what, let's actually use const, with field const, and we can say .age, and now we can say person.age, and then we can go to raw age dot to int. And obviously, you know, this fixes the situation, but it's actually not ideal because this obviously can throw an exception. Now, I know that this video is getting kind of long, as most of my videos do, but as promised in the beginning, I want to show you an example with cats related to validation, which is a very typical, you know, gateway drug to functional libraries and functional programming in general. Okay, so before we do that, let me actually go and add yet another field. So I'm also going to have okay, so we have age over here. I'm also going to have height in centimeters, and this is also how the type is going to be called, height in centimeters. Okay, so let's go and do that. So we have age and we have height in centimeters, and over here as well, height in centimeters, and we're going to add it over here as well, height in centimeters, height in centimeters. Okay, like this, and we need to go to main and add it as well. Over here, age and height in centimeters, and centimeters equals, I don't know, let's say 170 or something. Okay, it's a string. That's exactly what I meant. Still doesn't like it. What? Typo or something? String. Oh yeah, yeah. What? No, but this is raw. Hold on. This is raw. Yeah, raw is string. Okay, like this. All right, there we go. Now Chimney fails. Now we need to go fix it like this. Okay, height in centimeters, and we're gonna do raw height in centimeters dot to int. What's wrong? Value passed over so person age. Is that a copy paste mistake again? No, that's height in centimeters. That's height in centimeters. That's a string. What am I doing wrong? Height in centimeters, raw height in centimeters. Oh, here. This one. Like that. Over here. Types are awesome. All right, so let's go ahead and add the dependency for cats. We're going to go back to build, and now we're going to do dependencies dot, let's just do cats, and we're going to do cats core like this. Okay, and now let's go to dependencies. By the way, this is a new thing in SPT that I realized that something changed and it went crazy. It tried to reload the project and it obviously failed because we don't have this one yet. Okay, so this is going to be val cats core, and it's going to be org.type level and cats core, and we're going to do 2.0.0 like this. Let's retry that. All right, and let's also not forget to import the build. I want to wait until SPT is happy at least. All right, let's go and import the build. Okay, cool. So the first thing that we're going to do is we're going to go and actually don't need this notification. Go away, go away. I want to see my terminal. Okay, we can close the build. We can close the dependencies, and for now we can close the structure. Actually, let's leave just the main. Okay, so the first thing that we're going to do is we're going to go and we're going to import cats.implicits like this. And I'm doing this because we're going to have a tiny helper. Where are we going to have it? Let's go and have it. Let's go and have it at the top. Okay, so I'm going to go and have a tiny helper. Okay, it's going to be called int or error message. Okay, I'm going to show you why we need the implicits just in case. We actually need it only in a couple of places. So let's just say, so this is going to be a helper. So we're going to give it a field, which is going to be a string. Okay, and we're going to give it a field name, which we only going to use for the error message. So it's going to be a by name parameter, right? So because we only need it in the error message case. Okay, string. Okay, so now we're going to use either, which comes from Scala, and in fact, I believe we actually have never discussed either. But essentially, either is an anonymous coproduct, right, or anonymous sum type, right? So it basically can be either this or that. Okay, so usually the type on the left is used for the error message. In our case, it's going to be a string, and if everything goes right, then on the right of the either, we're going to have an integer. Okay, so now we can go over here and we can say either dot, and this is where cats implicits come in. So we have this thing called from option. Okay, so we can basically give it an option. Okay, we're gonna go to the field, right, which is basically the string was the age, for example, that we passed in, and this is the thing that was added in Scala 2.13 finally, because literally everyone was redefining this. There's a way to convert to an int safely, right? So it's called to int option. Okay, so from option takes the option, right, and then if it's a none, and then it also needs the error message, and we're going to have a fancy error message. In fact, I'm going to copy paste it so that I don't waste your time. Going to paste it from my script like this. So basically it's just a string that I'm pasting, right? Because it's either going to be an integer or a string. Okay, so basically it's going to say field name, which is exactly why it's a by name parameter, because we're not always going to use it. It must be a valid integer, which field was not. Okay, it's going to display the whole thing in rad as well. Okay, so this is going to be that. And another thing that we're going to add is that either has a helper method called filter or else, right? And over here we can basically add another predicate, right? So we can say we also want to make sure that this thing is greater or equals 0. Okay, and if that's not the case, then we can essentially produce yet another error message. Okay, so the semantics are actually kind of simple, right? So if this is an integer, then this error message is not going to be, displayed, right? So it's going to be a right over here. So it's going to be either dot right was the integer, and after that we're still going to validate this integer that is still greater than 0, and it's so there's still a chance to fail. Okay, so this is how you validate the same field more than once. Let's see if this compiles, and it looks like it does. Okay, so we have this helper, and the only reason we had the cats implicits was for this method, right? So if we jump in there, we're going to see that it's in cats. Now we're going to go ahead and add yet another helper, right? Because cats, you might not be familiar with cats. Cats, is a functional library. Functional things are very, very abstract. So I want to create as many helpers as possible. Okay. So in fact, the helper that I'm going to create now is going to be longer than the actual implementation of the helper. Okay. But, I just want to say that it's going to be a map to validated NEC. Okay, so it's going to take a parameter with some result, and all it's going to do is going to take this either, the one that we're producing over here. So it's going to be either a string or int. I'm going to call it either, right? Paste, right? So essentially, we're going to call this helper. Whatever is going to come out, we're going to stick it into here. Okay, so it's going to take our either, and we're going to take a function that will transform the right case. Okay, so if it's an integer, then we're going to transform it to the result. Okay, so this is why it's called a map, right? It's a very, very, very simple helper. So what it's going to do, it's going to map the value, but it also is going to transform the either into a so-called validated neck. So Cats has a concept of validation. It's basically very similar to either, in a sense that something can be either valid or invalid. So it has a valid case and invalid case. Either has a right case and left case. The major difference between them is that either can basically gather only one error message, whereas validated can gather multiple error messages, which is why it is very common to use a validated where on the left you're going to have some sort of bunch of errors, right? So in our case it's going to be a bunch of strings, so you would use something like list of string. Okay, and Cats comes with its own data structures for list. It has a version of a list which can never be empty, right? It's called non-empty list. It also has a thing called chain and a non-empty chain, and they're basically exactly like list, but they also allow you to append things faster, which is exactly what I need. So over here, essentially, we want on the left of the validated, essentially in the invalid case, we want to have a non-empty chain, right? And on the right, we're going to have our result. Okay, and because this is such a common case to have this non-empty chain on the left, there's also a thing called validated non-empty chain, like this. Okay, and now we only need to specify what is going to be inside of this chain, which is the string, right? So our error messages are going to be strings. If you've never played with Cats, or if you don't have much experience with parametric kind of programming, then this might be a little bit too much, but actually it's actually super simple. Okay, so we're just taking the either, we're calling map with this function transform. Oh, that's new. Oh, no, it's not new. It's just that we got comments there, and the comments are also displayed here. Interesting. That's cool. Okay, so essentially we map to transform, and Cats comes with a helper function called toValidated. Not that one. Validated neck. Let's see why we actually didn't get auto completion. Probably because we need some more things. We probably need to import Cats data. I think it's Cats data. Maybe Cats as well. Import Cats. I always forget where things are. No, maybe I did something else wrong. Okay. Oh, and should be capital. Yeah, there we go. And I actually believe that we didn't need this one. Yeah, we're gonna need it later though. All right. So okay, so this thing basically it looks at an either, it converts it to validated, and then all it does is it's creating a non-empty chain. It puts the thing inside, and then you basically have a non-empty chain with only one error message if the validated was invalid. Okay, so now we have these two helper methods. We have this int or error message, and we have map to validated neck. So what I'm going to do now is I'm going to go to our person, and I'm going to basically comment this out. Basically, let's comment the entire thing out like this. So basically, essentially now, I don't want this to be a person. I want this to be a validated neck, right? So basically, this is the thing that comes out from this last helper, validated neck. This one has a string in the result, and what we're going to have is string, and our result is person. Okay, so basically we want to have that. Let's do null for now, just so that things compile. Okay, so we have the raw person, but this one is a null. All right, so the next thing is a bit complicated, and I'm not going to explain it in depth because otherwise it's going to take forever. So basically, we're going to grab a fancy tool from Cats. I'm just going to do that. This is going to be some fancy tool, okay? And this fancy thing is going to have a function called map2. Okay, and it's going to be a current, not that one. So it's going to be a current function, right? So there will be two parameter lists. The last parameter list is a simple one. This is the one where everything, everything went fine and dandy, and this is basically the happy path. And in the end, so what we're going to have here is a function that everything went fine. So we have the age over here, and we have the height in centimeters, right? So they are already properly typed. This one is person.age, and this one is person.height in centimeters. And we're going to have the arrow to the right, and we essentially over here we're going to use Chimney to actually construct the actual person. Okay, so we're basically going to have the code that we had over here, right? So we're going to go and we're going to say raw into person, okay, and then we're going to say with field const, right? Because now we have the actual value, and we're going to say age is age, and we're going to say over here height in centimeters is height in centimeters, right? So this part is, this is a simple one. Again, this is just the happy path, okay? But this one is a bit more involved. So map2, it wants two of exactly these things, right? Which is exactly why we have this helper, okay? So the first thing that we're going to do is we're going to call this one, whatever comes out, we're going to stick into that one, and whatever comes out, we're going to stick into map2, and we're going to do this twice because we have two fields. We have the age and we have the height in centimeters, okay? So essentially, over here, I'm going to press enter, and I'm going to type exactly the calls to these guys. Okay, so we're going to say int or error message. Okay, now it wants the field, right? It wants the field, which is age, raw.age, which is a string, and it wants to have the field name just in case it needs to display the error message. Oops, I pressed enter. Okay, the field name is just going to be age. Okay, and the second thing that it wants, if I press Control KI, it should show me. No, hold on, I'm going to save it. Okay. Come on, show me. Why are you not showing me the signature? In any case, the second thing that it wants is, hold on, we already have that. Oh yeah, we already have that. So this one is done. Now we need to stick the result into this other helper, which is called map2validated, which wants this either, and it wants the function that will transform this integer. Basically, it will lift it into this proper type. Okay, so we're just gonna call this thing, right? And how can we convert an integer into person.age? Well, we're just going to do person.age, right? Which has an apply method, okay? And then we're going to do the same thing for in the height in centimeters. So we're going to do height in centimeters. Over here, height in centimeters. And over here, we're going to have person height in centimeters. Like this, okay? So at this point, it should almost compile unless, except for the fact that we don't have this fancy thing, okay? So let's talk about this fancy thing. So this fancy thing comes from cats, and it's called apply. So this is why we need this import. Okay, as already mentioned, I'm not going to explain apply, okay? So all we need to do over here, we just need to say apply validated nag with a string and something else. Okay, so if I'm going to have it like this, I believe it actually already should compile and it already should work. But essentially, this is the kind projector plugin. This essentially says that we're going to produce a validated nag over here, right? The error messages are going to be string, but the thing that is produced on the right, it will vary, right? So in this case, it's going to be person.age. In this case, it's going to be person.height in centimeters. And then at the end of the day, it's going to also become a person. And if you're not familiar with the kind projector plugin, this essentially boils down to this. Okay, so if we have a type alias, we're going to call it validated nag, where one of the types is fixed to be a string, okay, and the other one is not. Okay, so essentially it's going to be a validated nag where the type, the error message type is fixed to be a string, and the other one is not. Okay, so now instead of that, we can simply use this type that we have like this. Okay, this is exactly the same thing. So in our case, we actually don't need the kind projector plugin because this is just one line. And yeah, so that's basically it. Okay, so essentially the kind projector plugin and this type alias, what it does is it basically adapts a type with two type parameters into a type that wants only one type parameter. Okay, so let me actually go and grab this one. I'm going to inline everything like this, and then we're going to go and play around with our data. Okay, so okay, so let's see. Let's also have an empty, not an empty, but let's have a tiny print line over here just to split them up. like this. Okay, so we have the person and we have the valid in this case because everything went well, right? So we have a valid person name, Bob was age 37 and height 170. Let's go and ruin this a little bit. So let's go and say, where's our person? Person. Okay, so let's say that the age was actually not an integer, right? So let's say just do something like that. Now it's going to say, hey, this is now an invalid bunch of errors, right? So it's an invalid chain of errors, and because we made them red, remember, where are they? Over here, right? So we use the ANSI codes to make them red. This is why it actually kind of looks so fancy. Looks fancy. Okay, so now it says invalid chain age must be a valid integer, which ADF was not. Okay, so let's go and actually make it a valid integer, but let's make it negative 50. Right, so now it's going to say age must be greater or equal than 0. Now this is happening because we have, where's our helper? Because we have this filter or else. By the way, if you jump into filter or else, it's a very, very simple implementation, right? It basically says, hey, if it, if this either, if it's valid either, if it's the right one, then, just check again. And if it fails, then convert it into a left one and pass in the error message, which is called 0 in this case. Right, it's very simple implementation. Okay, so now we can go and also ruin this one because we're using validated, and in contrast to either, validated actually can accumulate the errors, right? So this is exactly why we use it. Okay, so if this one, for example, is not an integer, right? Some crap like this, then we actually see both error messages. We see that the age must be greater than 0, which negative 50 was not, but height in centimeters must be a valid integer, which ADF was not. Right, and all the error messages are going to work for this one as well, right? So we're getting invalid chain, blah blah blah. This is basically how validation is properly done in Scala. This is a very, very, solved problem. Okay, let's go back and fix this. Height in centimeters is going to be, I think we used 170, right? So now if all stars align, then actually it becomes a valid instead of invalid. Now, in case you have never played with scats, and yes, pun intended, then, this method, it might look a bit like sorcery to you, but, if you play a little bit around with scats, then you actually, it's actually not that hard, and I'm sure that we're going to have more and more videos about functional programming topics in the future. They seem to be kind of popular. Everybody knows how to program functionally these days, which is good. Great. Right. So before I leave, I'm going to add one teeny tiny more thing because we're going to need it in the upcoming videos, and I'm going to copy paste a bunch of stuff, so it's not going to be it's not going to take forever. Essentially what we have here is this raw type for the person. I want to have also so this is the raw type is still nested, right? It's a bunch of strings, but it is still nested. What I want to have is I want to have also a flat version. So the first thing that we're going to do is we're going to go over here and I'm gonna rename it to nested, like this. Nested, and this is going to become more important in the next videos, but the next videos aren't going to be about Chimney, but we're still going to build on top of the same example. So I want to finish like all the things that that relate to Chimney. Okay, so so let's see where it doesn't compile. Let's actually switch to this one. Does it show me the file? Yes. So this everything here is in main. Okay, so basically we just need to go and do over here. These ones are nested. Oh yeah, that was fast. All right, so the next thing that I'm going to do is I'm going to go and I'm going to create an object here, probably a case object raw. Okay, and inside of it we're going to have the nested one. Okay, let's do also over here we would need to do something like that person dot raw dot nested. Okay, and we probably need to fix that as well. Raw.nested, and the same thing over here, raw.nested. All right, so now we can go ahead and create a flat version of this. In fact, I'm going to go and just copy paste that. Okay, so I'm going to do that. Okay, so we have raw, we have the nested version, and we have the flat version, right? A bunch of strings, fields are renamed like this, and I believe we need another one of these. Okay, so we have raw and flat. And this is exactly why I added them, because I want to go ahead and add helpers over here to convert between, between both of them. And, Chimney is going to help us that. Okay, so we're going to go and say there's going to be a lazy val to flat, which is going to return flat. Okay, we're going to import address, right? So that we can have this kind of like flat feeling over here. So we're going to do into flat. And so Chimney already helped us converting these ones, name, age, and height in centimeters, because they were, and also phone, because they were, they were flat from the very beginning, right? So we don't need to do these two, but we actually need to do, the ones for address. So we need to do was field, not computed. I wanted the const, and we're basically going to do city name, city dot name, right? Because we're importing address, we can just do city dot name, and let's do that. No, actually 4 is enough. Okay, so this one is city zip code, and over here we're going to have zip code, and over here we're going to have street name, like that, and over here we're going to have name, and over here we're going to have street, and over here we're going to have number, and over here we're going to have street number, like this. And we're going to do transform. Let's see if I made any mistakes, and it looks like I didn't. Okay, now let's go to the bottom one and do the reverse. So we're going to go and do the two nested. So I'm going to have lazy val to nested like this. So I'm going to go this into nested like this, and we're going to do with field const, and this one is going to be address, right? But address is a very, very nested type, and this is why we're going to have like this only one call to with field const. We're going to construct an entire address over here, and at the end we're just going to say transform, right? So this is one of those cases where this is exactly what I meant, right? So if the hierarchy doesn't really match, then Chimney is not, that super useful, but at least, at least it copied the things that were flat for us. Okay, so all we need to do is just to create a raw address with a city.raw. Okay, over here we can just say city name and a city zip code, and over here we're going to do street.raw. We're going to have street name, and we're going to have street number, like this. I believe I have everything. Yeah, so now we can go from flat to raw, and from raw to flat. So now we can actually go, and I'm actually gonna copy that flat. Okay, so we can go over here. So instead of creating this raw, which is a bit more complicated than creating a flat, right? So we can do that. So we can do person dot raw dot flat, which is over here, person dot raw dot flat. Okay, so we have flat. I used exactly the same data except for the age, right? So age and height, right? So now over here, instead of constructing that, we can just do flat dot to raw, and the whole thing should still works. I'm sorry, I used to call it to raw in my early versions. Okay, flat to nested, right? So essentially it's exactly the same thing. We can also go and print out flat as well. Print out flat like this. Okay, so okay, that's not helpful. Let's do it again. Okay, so this is the flat one, right? Same data. This is the nested one. So both of them are raw, just the strings. And then once we actually convert them, we have the valid with all the types where everything matches, everything is perfect. Great. All right, that's pretty much all I wanted to show you today. Take Chimney for a spin. Even though I said a couple of negative things about it, it actually seems pretty solid. For what it's supposed to do, it actually does it really well. Okay, and I know you guys want more functional programming videos, and I'm sort of working on them, at least in my head. And it's super easy to explain functional concepts wrong, and I want to do a really good job, there's only 24 hours in a day, and I'm just one guy. Okay, so be patient. They're coming. All right, as always, I'm sorry that this video was way too long. As always, it's been Vlad, devinside.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you learned something today, consider supporting me on Patreon. But most importantly, take care.